In the early morning of June 30, 1908, a massive explosion rocked the remote Tunguska region of Siberia, flattening over 2,000 square kilometers of forest. This event, known as the Tunguska explosion, remains one of the most intriguing mysteries in the world of physics and natural phenomena. Imagine waking up to a blinding flash of light, followed by a shockwave that rattles windows and sends trees crashing to the ground. That's exactly what happened to the few residents living near the site. But what caused this cataclysmic event? For years, scientists have debated the cause of the Tunguska explosion. The leading theory suggests that a meteoroid or comet entered Earth's atmosphere, disintegrating at an altitude of about 5 to 10 kilometers. The energy released was equivalent to about 10-15 megatons of TNT, which is roughly 1,000 times more powerful than the atomic bomb dropped on Hiroshima. This explosion didn't just create a loud bang, it also produced a fireball that could be seen from hundreds of kilometers away. The heat was so intense that it ignited trees, creating a scorched landscape that looked like a war zone. But what exactly happens when a meteoroid enters the atmosphere? As it descends, it encounters air resistance, which causes it to heat up. This process is known as ablation. The meteoroid can break apart due to the intense pressure and heat, creating a series of smaller fragments. If the object is large enough, it can explode in a brilliant flash before reaching the ground. The Tunguska event serves as a reminder of the power of nature and the potential threats posed by near-Earth objects. Scientists have since developed methods to track these celestial bodies, hoping to prevent future disasters. Interestingly, the Tunguska explosion didn't just leave behind a flattened forest, it also sparked a wave of scientific curiosity. Researchers flocked to the site to study the aftermath, leading to significant advancements in the fields of physics and environmental science. One of the most fascinating aspects of the Tunguska event is the way it challenges our understanding of impact events. Unlike typical meteorite impacts, which leave behind craters, the Tunguska explosion produced no crater. Instead, it created a radial pattern of fallen trees, with the most destruction occurring in the center. This phenomenon is known as an airburst, where the explosion occurs in the atmosphere rather than on the ground. The airburst theory has been supported by various studies, including simulations that recreate the conditions of the explosion. These simulations help scientists understand the dynamics of airbursts and their potential effects on the environment. In addition to the scientific implications, the Tunguska event has also inspired countless works of fiction. From novels to movies, the mystery of Tunguska has captured the imagination of many. It raises questions about the unknown and the potential dangers lurking in space. As technology advances, the ability to detect and track near-Earth objects has improved significantly. Programs like NASA's Near-Earth Object Observations aim to identify and monitor these celestial bodies, assessing their potential threat to Earth. The Tunguska explosion serves as a crucial case study in planetary defense. Understanding the physics behind such events can help scientists develop strategies to mitigate potential impacts. In recent years, researchers have also explored the possibility of using nuclear devices to deflect or disrupt threatening asteroids. While this concept may sound like something out of a sci-fi movie, it's a serious consideration for planetary defense. The Tunguska event is not just a historical curiosity, it's a reminder of the dynamic and sometimes dangerous nature of our universe. As scientists continue to study this phenomenon, they uncover more about the forces at play in our solar system. In conclusion, the Tunguska explosion is a fascinating intersection of physics, astronomy, and environmental science. It highlights the importance of understanding the risks posed by near-Earth objects and the need for ongoing research in planetary defense. The legacy of Tunguska lives on, inspiring scientists and storytellers alike to explore the mysteries of the cosmos. So the next time someone mentions the Tunguska explosion, remember it's not just a story of destruction, it's a tale of scientific discovery and the quest to understand our place in the universe. This event continues to resonate, reminding everyone that the universe is full of surprises, and sometimes, those surprises can be explosive.